Hello and welcome back. Today's date is March 23rd, it is Monday, and this is a review of the Honors Volume Review that was posted on Google Classroom the same date. My recommendation is do not watch this video until you have already completed as much of this as you can. This isn't collected, this is something that you need to complete on your own and then review with the video to see how you did and see how well you're grasping this material. For number 1 is just finding the volume of a rectangular prism. As you may have learned from the Orange Book activities and from Edgenuity, volume of a rectangular prism is just length times width times height. All you do is multiply those three numbers together, and this is a calculator active unit. So this is 11 times 13.5. So for this type of calculator, we would hit our fraction button, move to the left, enter 13, move to the numerator and the denominator, and then out of the fraction. So 13.5 times 5. Now our calculator, this kind, the TI-30XS Multiview, will give us an improper fraction. If you want to take this and turn it into a mixed number, you will have to activate this using the second button. This little neon lettering is activated when you push the second button. That appears in the corner, and then you click the button underneath the neon lighting or writing, and that will activate the button. So now it will turn that mixed number, or that improper fraction, into a mixed number to give us 742 1/2. So the answer for us is D. Number 3, it only gives us one side. It says a cube has an edge length of 2/3 of an inch. What is the volume of the cube? Well, a cube, you could still do length times width times height, or since it's a cube and all the sides are the same, you could just do the side to the third power. So we can do 2/3 times 2/3 times 2/3, or with this calculator, if you want to set a power that is other than 2, you will use this little chevron right here, a little upside down V, and that will allow you to type in whatever number in the corner you want. In this case, we want a 3, so we need 2/3 to the third power, and that gives us 8/27, which happens to be D, our correct answer. For number 3, by the way, I should mention, if you are checking this and you already know for sure which ones you got right and wrong, you can skip ahead to the problems that you might need help with. Number 3, rectangular fish tank has those dimensions. How much water will be needed to fill the fish tank? Once again, just straight multiplying. 12.5, so that is 12 1/2 times 16 1/4 times, we've got 16 1/4 times 8. And that gives us our answer of 1,625, or 1,625 cubic inches of water. Number 4, the first one some of you might have gotten wrong or might have been stumped on. It's saying that this fruit company ships boxes of apples and pears in crates that measure those dimensions. The apple box measures those dimensions, and the pear box measures by those dimensions. If one box of each fruit is placed inside of the crate, what part of the crate is not filled with fruit? So step 1, we need to know the entire large crate. We need to know the dimensions of the big box. And then it tells us that there is going to be a box of apples inside of this crate. And then it says there will be a box of pears in this crate. Now, obviously, this is not drawn for scale. I just drew 2 smaller shapes inside of this big shape to represent what is happening. So my apple box is going to be those dimensions, pear box, whole crate. We'll start with the whole entire crate. the whole entire crate will be 15.5 by 18.5 by 24. So 15.5, I'll take a shortcut and just do this as decimals. 15.5 by 18.5 by 24. That gives us a total volume. This entire crate will hold 6,882 cubic inches. 6,882 inches cubed. That's our whole crate. Next, we'll do the apple box. The apple box, which is, I guess this one's the larger box, so I'll call that one box A for apples. We've got 15 by 15 by 10.5. So once again, just going to take a shortcut and call that 10.5. And 0.5 I know is a half, so that's 2,362.5. So that is 2,362.5 inches cubed. And last but not least, the pear box. My box of pears is going to be 12 by 12 by 12.5. So 12 times 12 times 12.5. Now that's going to be 1,800 inches cubed. Now, in the question, it asks what part of the crate is not going to be filled with fruit. So what you have to do for this is you need to take the total amount of space, that 6,882 inches, and you're going to need to subtract the two amounts that you got for the other smaller boxes. Because these two boxes are going to be taking up space containing fruit in the box, and we want to know how much space is not going to be occupied by fruit. The reason a company might want to know this is so that they know how much bubble wrap or how much packaging material they need to put in order to protect their product as they're shipping. So we're just going to subtract 6,882 minus 2,362.5 minus 1,800 is going to give us 2,719.5. 2,719.5 inches cubed. That is the space that is going to not be filled with fruit. Now, in case any of you got A, that's because you got lazy and stopped after the first step. Anyone who got D, again, you were lazy and stopped after the final step. If you got B, you found how much space is occupied by fruit. What you did was you had added these two amounts, but did not take away from the larger volume of the crate. That's where B came from. For number 5. Number 5, back to a simple volume problem. It just wants you to multiply width, length, and height of this shape. It is really hard to see on this paper, but those are each thirds. This is 2/3, 1/3, and 1/3. So we have 2 2/3. So that is 2 2/3 times 2 1/3. So 2, I shouldn't have hit that number first. 2 1/3 times just 1/3. And that's going to give me 56/27. That's clearly not an answer choice. You could do a little bit of inferencing, and you could say that 27 will go into 56 2 times, and you can infer that the answer should be B. Otherwise, you can do that handy little second and then your mixed number conversion button to confirm that, yes, the answer was B. Moving on. Number 6. It's asking which box will hold the least amount of material. If you got this problem wrong, it was probably for just some dumb mistake. You accidentally chose the one that held the most. So all we're going to do is find the volume of each of these containers. Move this over so I can type and you can see what I'm doing. Box A is, or X, what letters were they? W. Whoops. So box W is going to be 2 1/4. I'm going to cheat and put them in as decimals because it's quicker to enter. Times 2 times 3. And that gives me 13.5. So 13.5. The next box is 2 times 2.5 times 2.5. That gives me 12.5. Next we have 2 times 4 1/4 times 2. That gives me 17. And lastly we have 2.5. Whoops. We have 2.5 times 3 times 3. So that gives me 22.5. If you chose this answer choice, if you chose C, you may have gotten tempted by that just because you saw that 4 1/4 is the largest amount. Not quite. That is the larger amount, but it's being multiplied by 2 smaller numbers. This one, all 3 of the numbers are at least 3 or larger. None of the other options really have that going for it. D is going to end up holding the most, which is not what we want. I almost got the answer wrong because of a dumb reason. I forgot. We're trying to find the least amount. That's going to be X. This is why it's important to slow down. Even teachers can make mistakes. So, number 7. We've got the interior of a rectangular box has a width of 5 inches, a length of 7.5, and a height of 7 1/4. Tom is putting cubes inside the box. Each cube measures 1 1/4 inch. So this one, we're actually going to be not just finding the volume. We are going to start by doing length times width times height in order to find the volume of that larger box, that rectangular shaped box. So 5 times 7.5 times 7.5. So that's going to give me 281 1/4. So the total volume is 281 1/4. That's inches cubed. That is not the number of cubes, though. That is just how many inches cubed are inside of this larger box. It then tells me that each cube measures those sides. So there are 2 ways you can go about doing this. Option 1 is you can figure out how many times 1 1/4 will go in to the width, the length, and the height, and then you can multiply that new amount. I find that the quicker way is to find the volume of the smaller cubes first. So, the smaller cubes volume is going to be 1/4, or 1 1/4 times 1 1/4 times 1 1/4. That's going to give me how much space each one of these tiny cubes is going to take. So, take my shortcut and just do 1 1/4 to the 3rd power. And that tells me that each cube, we fix that a little bit and turn that into a mixed number, 1 61 64ths. 61 64ths inches cubed. So that's how much space is taken up by the smaller cube. Now, if you're trying to figure out how many small cubes will fit inside of a big cube, well, you can kind of tell just based on that phrasing what is the maximum number of cubes that can fit inside of the box. That's going to be division. We have to do 281 1/4 divided by the volume of those smaller cubes, 1 61 64ths. So, we're going to do 281 1/4. So 281 1/4 divided by, that is going to be 1 61 64ths. We can fit a total of 144 smaller cubes inside of this space. That is going to be my answer. And unfortunately for a lot of people, 281 was an answer choice. They were waiting for you to get that, but they were hoping that, I was hoping at least, that you would realize they had rounded, but the question did not give us any hints that they wanted an approximate answer. They wanted an exact answer. So no rounding. For number 8, a candle factory packs large rectangular boxes with smaller boxes of candles. Once again, we're dealing with a smaller shape inside of a larger shape. So the interior of the large shipping box is going to be 3.5 feet by 4 feet and 2 feet. The smaller boxes are a width of 6 inches, 9 inches, and 1 foot. Already there's an issue. One shape is being measured in feet. One shape is being measured in inches. Your two options here are either to convert all of these inches into feet, which you can do, they're just going to be fractional amounts, or you can convert all of the feet into inches by multiplying by how many inches are in a foot. The inches to foot you would divide by however many inches are in a foot. So, the two ways we can go about doing this are we have the inches and we have the feet. For the large shape, 3.5 feet. So we have 3.5 times 12 is going to be, let's see now, 3.5 times 12. That gives me 42. And we have 4 feet times 12. That's going to be 48. And we have 2 feet by 12. That's going to be 24. So my large box will be this in inches. My small box is going to be 6 inches by 9 inches by 1 foot. That's 12 inches. Okay? However, if I go with the option of feet, let me grab a different colored pen. For the options of feet, my large box is going to be 3.5 by 4 by 2, and my small box is going to be 6 inches, that is half of a foot. My length, 9 inches, that is 9/12, which simplifies to 3/4, and 1 foot. So these are my options. I could either do things in inches or in feet. Neither one is wrong. Both of them will work. For feet, for my larger shape, we have 3.5 times 4 times 2, and that gives me a total volume of 28 feet cubed. Whereas my small shape will be 1/2 times 0.75 for 3/4 times 1. And to convert from fraction to decimal and back and forth, you can click second and look for this FD button. And I'll turn it from a decimal to a fraction. And that gives us only 3/8 of a foot cubed. So the smaller cube gives us a fractional amount. In the world of inches, we have large, which is going to be 42 times 48 times 24. That's going to be 48,384 inches cubed. And the small is going to be 6 times 9 times 12, and that's going to be 648 inches cubed. What you do from here is exactly the same for both. You're just going to divide your larger box by your smaller box to see how many of those smaller boxes will go into the larger box. Starting off with the foot side, we have 28 divided by 3/4. So 28 divided by, sorry, not 3/4, 3/8 gives me an answer. 224 over 3. Change that to a mixed number to make it easier to read. That is 74 2/3 That is how many cubes will fit inside. Going back over here, we have 48,384 divided by 648, and that gives us, let's see, that gave me a decimal, so let's go ahead and convert that from fraction to decimal. And that is going to be the exact same thing. I can go ahead and do mixed number conversion, and that still gives me 74 and 2/3. I got the same answer for both of them. Now, I don't like the way they did this question, because based on this, we would say that the correct answer should be 74. They did not give us 74 as an option. 75 is not going to be an option either, though. The reason 75 will not be an option is we're trying to figure out the maximum number of smaller boxes that will fit inside of the larger box. Thing is, if only 74 and 2/3 of these boxes will fit, 75 will not fit. 1/3 of that final box will still be sticking out. So the answer isn't 75. I don't like that they made the answer 70 though. So if I were doing this on paper, I would change that to 74. Shame on this question. Number 9. Interior of the box looks like we have... I didn't just knock over my document camera. For this problem, it says the interior of the box in the shape of blah blah blah. I can't read. We have a box, and Maggie over here wants to put cubes inside of the box. So, larger box. Larger is going to be 5 by 6.5 by 4.5. 5 times 6.5 times 4.5 is going to give me 146 1/4 inches cubed. And the smaller box is going to be 1.5 to the 3rd power. That is going to be 3 3/8 inches cubed. Now we just do the process of dividing my larger shape by my smaller shape. So 146 1/4 divided by my previous answer. That is going to give me about 43 1/3. This problem did things correctly, although they did not give you 44 as an answer choice as they wish they would. For this one, 43 1/3 of the boxes will fit inside of that larger shape, and they correctly rounded down to 43. Not just because 1/3 is less than half, but simply because if 43 1/3 of a cube can fit inside of that larger box, therefore that 1/3, that final box, is just not going to fit. For number 10, a simple volume problem. They're just asking what is the volume of a prism that has dimensions of 7 5/6, 1 1/3, and 36, all measured in meters. So for this, we have 7 5/6 times 1 1/3 times 36. And that gives me an answer of 376. More than halfway there. Number 11, just asking for the volume of this juice box. That is going to be 9 by 6 by 3.5. And that one should be... I got 189. 9, 6, 3.5, about. Almost missed that key word. Since it says about, we are safe to round up from here. That is going to be much closer to 200 than 100. Sorry for the pause, but I missed the word about. Number 12 looks ultra complicated right up until you read the question. It is asking which expression shows another way to find the volume of this prism. Well, for starters, let's just look and see if length times width times height is an answer. 4.5 times 1.5 times 4. Hey, look at that. It's right there. That's all this problem was asking, was how do you find the volume of this? Not terribly difficult. The next problem. It is trying to find out a box that will measure exactly 98 cubic feet. Only one of these will equal exactly 98 cubic feet. We just have to figure out which one. So we'll just start going through the list. The first one is 14 times 1 times 7.5. Nope, A is out. The second one, 5 times 6.5 times 3. Nope, very close. Very, very close, but not quite. He wants exactly. Next one, 2 times 7 times 6 1/4. Still no. We can assume the answer is D since nothing else got it, but let's double check. 4 times 3.5 times 7. Yep. That's the only one that got us exactly 98. For number 14, this is the first problem that mentions a base area, or area of the base of a flower pot. Now, in one of the help videos I posted last week, I mentioned something like this. Or at the very least, there were some example problems in the Orange Book that did this. They were saying that if you know the area of the base of one of these shapes, say you know the area of this shaded blue base right here. If you know the area of this, that means you have already done length times width. And the only thing you still have to do is multiply by the height. So for this problem, area will equal area of the base times my height. So for this, we're just going to do 72 times 7.5. And that gives us 540. If you had multiplied 72 twice or multiplied by some combination, you would have gotten an answer way too big for any of those answer choices. For number 15, Maggie had exactly 90 cubic inches of water. She poured the water into the container in the shape of a rectangular prism shown below. The dimensions of the container are given in inches. Based on this information, which statement is true? If you read over the answer choices, it looks like a lot of these answers are talking about how much water is left over or how much room is still left in the container. So one way or another, we need to do some subtraction along with our volume. So step 1, find the volume of this shape. We're going to do 3.5 times 5 times 7 1/4. That's going to give me a volume of 126 7/8 cubic inches. We also know that she poured exactly 90 cubic inches of water. So for the water, we've got 90 inches cubed. In order to find what space would be left over, so we have that much space in here, the water comes up to, we'll say about there. That's where the water comes up to, because 90 is less than that. So we're going to have space left over in the box. So we're definitely not going to have any water left over. A and B are out. And to figure out what's left over, we will subtract 90 from that amount. Convert that to a mixed number. So leftover space we've got 36 and 7/8 cubic inches. Well, let's see which answer choice reflects that. Maggie added all the water to the container and had 36 and 7/8 cubic inches of space left in the container. Sounds right to me. Number 16, one of my favorite type of problems. It's a type of problem that gives you everything you need to find the volume. And it gives you volume as an answer choice. And volume is the wrong answer. If you go through this problem and ignore those tiny cubes and decide to just do 4.5 times 2 times 1.5, you will get 13 and 1/2. 13 and 1/2 is not even an answer choice. It's not something that you can use. I think I said that volume was an answer choice. Oops. Yeah, no. It's asking you how many cubes are needed to completely fill the box, and it tells you each one of those cubes is 1/2 of an inch on each side. There are two different ways you can go about doing this problem. Option 1 is the finding the volume of the whole shape, and then finding the volume of the smaller boxes. And then you can divide them. So the total volume is 13.5 inches cubed. The volume of the smaller boxes, well, the smaller box is just going to be 1/2 to the third power, which is 1/8. And then you would divide those two amounts. That's the same method we used for two other problems in this review. And if you do 13.5 divided by 1/8, you will get the correct answer that 108 cubes can fit inside. The other way you can go about doing this, and this only works really when you have a picture to go along with it, so this won't help you on some of the previous problems. But if you have a picture, you can count up how many boxes are necessary for the length, width, and height. For the length, 1, 2, 3, 4, 5, 6, 7, 8. We have 9 cubes for the base, or for the length. 1, 2, 3, 4 for the width, and 3 for the height. You could do 9 times 4 times 3. That would also get you 108 for the answer. The last way you could do this, and this way is probably the most tedious, is you can multiply the length, the width, and the height, or not multiply, you can divide the length, width, and height by 1/2 for every single one. And that's going to give you 9, 4, and 3, then you multiply them and you get 108. The reason I mentioned this one first is because it's the most straightforward and it works with or without a picture. Those other two methods that I just mentioned, they won't work unless you have a picture to go along with your problem. And that's just not going to always happen, like the first two times we saw this type of issue. For number 17, it is just asking the volume in inches of 1 cube of ice produced in this ice machine. It tells us that these ice cubes are 3/4 of an inch on each side, so we could just take 3/4 and put it to the third power. That is going to be 3 times 3 times 3 for the top, and 4 times 4 times 4 for the bottom. I don't even need my calculator for this one. 27 over 64. And for the final problem, number 18. Number 18, they don't give you quite as much information of this. It just tells you that there is a grand total of 432 identical cubes, and that each length of the cube is measuring 1/2 inch long. The best way to go about doing this is to go ahead and figure out what all of these dimensions would be. So we've got 1/2, 1/2, well that's 1. 1/2, 1/2, that's 2. 1 half, 1 half, 3, half and half, 4, half and half, 5, half and half, 6. So the length equals 6. Next is the width, which we have 1, 2, 3. And the height, we have 1, 2, 3. So that's your first option, is to go through and figure out what the length, width, and height would be, and then multiply them. 6 times 3 times 3. And that should give you 54. Another option that you have for this problem is when they tell you how many cubes will fit and they tell you the dimensions of the cube, and this will work especially well if you don't have a picture to go along with this type of problem. In the 6th grade, they will always give you a picture to go along with this type of problem. However, you need to be prepared for the inevitability that they won't. So, we have the number of cubes and the dimensions. You could do 432 times the measurement of the length reduced by half, the width reduced by half, and the height reduced by half. Because if you recall, that's how many cubes there are. Great. Now multiply it by the dimensions of those cubes, length, width, and height, half, half, and half. If you go about doing it this way, 432 times 1 half times 1 half times 1 half still gives me 54. I was just being lazy and typing in the decimal version instead of the fraction version. But either way will work for that type of problem. And this is it for the review for our honors assignment from March 23rd. Sorry it ran a bit long. Hope it helped.